Alright, ladies and gents, we are going to take a little deeper step into matrices and the use of inverses, and we're going to use them to solve systems of equations. Now, remember, systems of equations is a group of 2 or 3 or more equations, and we want to solve for every variable. We're going to use matrices in this fashion. So, we need to remember that a matrix A times its inverse is going to be the identity matrix of some width and length, so some n by n matrix. We should know that if we multiply the identity matrix times some other matrix, we're going to get back the matrix. That's what identity means. When you multiply something by the identity, you get the same thing in return. So say we have a system of equations, 7x minus 3y equals 1, 4x minus 5y equals negative 7/5. I want to solve that system of equations. We can use the methods we learned before, graphing, substitution, elimination, and I'm going to show you this last method using matrices. First, I'm going to rewrite this system of equations using a matrix. So I'm going to write down my coefficients. Okay, so this matrix represents the coefficients times our variable matrix equals the answer matrix. Alright, notice that if you were to multiply these two matrices, this is a 2 by 2, this is a 2 by 1, so you are allowed to do that. You would do 7 times x plus negative 3 times y, which is 7x minus 3y. And the second row would be 4 times x plus negative 5 times y, which is 4x minus 5y, and equals 1 and negative 7/5. So these are basically the same thing. We're just going to be using matrices now. So I'm going to represent these matrices using letters and variables. So our coefficients, I'm going to say that's matrix A. Our variables, I'm going to say that's matrix X, capital X. I'm going to say the answers is matrix B. So I'm trying to solve for X here. I'm trying to get this X by itself. So I want to get rid of this A. So looking over here, I know that A times its inverse is the identity. So I'm going to multiply the inverse of A to both sides. So here we have A times its inverse. That is going to be equal to the identity. So we have the identity matrix times the matrix X equals A inverse times the answer matrix. Identity times any matrix is going to be the same matrix, or itself. Okay, so all we need to do is if we find the inverse of this matrix, multiply it to this matrix, that will give us the values for x and y. Okay, so if we were to find the inverse of A, you would set it up as this: 7, 4, negative 3, negative 5, 0, 0, 1. And then you would do some arithmetic. I'm not going to show that just because that's not what this video is for. But basically you would end up with this matrix. And so we have our inverse. So then you would take your inverse, which is 5/23, negative 3/23, 4/23, and negative 7/23, and multiply it to your answer matrix. And that's equal to 56/5 and 11. And that would be your answer. So the answer is, let me move these things a little bit. So that means x is equal to 56 over 5, and y is equal to 11. Okay, so to review, we know that a matrix times its inverse is the identity. The identity times the matrix is the original matrix. So I split up our system of equations into a matrix of the constants, matrix of the variables, and the answer matrix. And if I multiply the inverse of the original matrix to both sides, we'll get the variables equals the inverse times the answers. We found the inverse. We multiplied to the answers, and we got these two numbers, which is our x and a y. And that's all there is to it. Sometimes you get really complicated ones, which is where matrices come into play. But other than that, that's where we're going to leave off.